Welcome to today's Explainer. We're jumping right into what's frankly the biggest paradigm shift in cybersecurity history, securing autonomous AI agents. We're moving incredibly fast from a world where humans securely access systems to a reality where autonomous software acts on our behalf. And let's be honest, our traditional security models, they are completely unprepared for it.
Just to wrap our heads around the sheer scale of this crisis, think about this number. By 2028, businesses are projected to deploy 1.3 billion AI agents. That's straight from Microsoft's recent insights. This fundamentally changes the scale of enterprise security. We're not just bolting on a few new apps here. We are essentially onboarding a massive, brand new workforce of digital employees that operate at machine speed.
So with this massive wave heading our way, we have to ask ourselves a pretty uncomfortable question. Are your security protocols actually ready for non-human identities? Because if your security architecture heavily relies on a human typing in a password or passing a multi-factor authentication prompt, how exactly does it handle an autonomous machine negotiating access with another machine?
Here's our game plan for today. We'll cover the agentic identity crisis, the confused deputy threat, zero trust for AI, dynamic identity and access, securing the agent estate, and finally, implementing technical defenses.
Let's kick things off with Section 1, the agentic identity crisis and this entirely new threat landscape.
The core issue here is that agents operate as non-human identities, or NHIs. They completely bypass the standard user login sessions we're all used to managing. I mean, an agent doesn't log in at 9 a.m. and log out at 5 p.m., right? It relies on machine accounts, service identities, and API keys. And because these totally lack traditional session-based oversight, the risk of token abuse just skyrockets if they aren't meticulously managed.
Old security models basically assume there's a human sitting at a keyboard. But when an AI agent interfaces directly with your database, that assumption turns into a massive vulnerability. We've spent decades building security around authenticating people. Now, we have to completely shift gears from authenticating people to authenticating intent and autonomous action.
Moving right along to Section 2, the confused deputy threat and weaponized autonomy.
This brings us to what is basically the absolute nightmare scenario for any identity management team, the confused deputy. This is a vulnerability where an AI agent with high-level permissions is tricked by malicious prompts into performing unauthorized actions. Without strict privilege isolation, the poor agent literally cannot distinguish between a legitimate user's intent and an attacker's injected instruction. It just executes.
The OWASP Top 10 for generative AI outlines some seriously severe scenarios here. An attacker might trick an agent into dynamically escalating its privileges to exfiltrate data. Or they could exploit cross-system authorization, like imagine an agent pivoting from a low-risk HR system straight into your highly restricted finance databases. Attackers can even deploy completely undetectable shadow agents or steal a long-lived API token to persistently take over a legitimate enterprise agent identity.
So if an agent can chain tools together in unexpected ways and figure out how to bypass restrictions, how on earth do we govern them? This isn't just theoretical stuff. Agents are specifically designed to problem solve. If they hit a wall, they're going to try to find a way around it using external APIs or tool chaining. If your security relies on static walls, the agent is just going to climb right over them.
The answer to that governance problem is simple but absolutely profound. Never trust, always verify. We have to completely eliminate implicit trust for any entity on our network, whether it's a human or a machine.
And that brings us directly to Section 3, Zero Trust for AI, the new paradigm.
Traditional security was all about giving broad access based on static credentials for an entire session. Zero Trust for AI demands something entirely different, continuous verification for every single machine action. No entity is trusted by default, no matter where it sits in the network. We're fundamentally shifting from log in once and do whatever you need to verify your identity and authorization for every single function you attempt to call.
If you're leading agentic AI identity management, your core mandate is to implement these components largely through policy as code. This guarantees that authorization dynamically adapts based on the agent's real-time behavior. Context-aware authorization checks if an agent is in a sandbox versus a production environment before it acts. Risk-adaptive authorization will dynamically revoke permissions the exact second an agent's trust score drops due to unusual behavior. It's security that actually moves as fast as the AI itself.
Now for Section 4, Dynamic Identity and Access, and how we effectively limit the blast radius.
Listen, if an agent's long-lived API token is stolen, the blast radius is catastrophic. Imagine a token just sitting there in a misconfigured cloud storage bucket. An attacker finds it, and suddenly, they literally are that trusted enterprise agent. This is exactly why static credentials are just completely unacceptable in a mature AI security posture.
Instead, agents need to use just-in-time or JIT access. They should be granted access to a tool only at the exact millisecond they need it, using ephemeral credentials that automatically expire the moment the task is done. On top of that, we absolutely need cryptographic agent attestation. This means every single time an agent is spawned or born, its identity is cryptographically verified and registered. That ensures unauthorized shadow agents simply cannot execute within your estate.
Let's look at Section 5, Securing the Agent Estate using the Microsoft Framework.
To pull this off, you basically have to become the lead detective of your own network. You have to proactively observe and control the entire lifecycle of your non-human workforce. You can't just set up a firewall and walk away anymore. You need unified, comprehensive visibility into everything these agents are attempting to do.
Microsoft lays out 4 critical steps here. First, discover your AI estate to prevent shadow AI sprawl. Second, manage access using risk-based conditional authentication. Third, govern the entire agent lifecycle, from birth all the way to decommissioning. And fourth, enable AI-powered runtime defenses to actively block malicious traffic and catch prompt injections the exact second they occur, preventing data exfiltration in real time.
Finally, Section 6, Implementing Technical Defenses. This is your architectural blueprint. When we map specific OWASP threats directly to your defensive architecture, the mitigations become super clear. Rogue agents trying to infiltrate a multi-agent system, they are stopped dead in their tracks by enforcing bidirectional mutual authentication, or A-to-A authentication. If Agent A wants to talk to Agent B, they both have to cryptographically prove exactly who they are. Likewise, if an agent is tricked into lateral movement, execution sandboxing prevents it from breaking out into the wider network. By requiring function-level authentication, meaning you verify identity right before an agent uses a specific tool, and sandboxing every single tool invocation, you guarantee that even a hijacked agent can't breach the broader network. And this is absolutely crucial. You must enforce immutable cryptographic audit trails. Every decision and data access has to be transparently logged so you can partner with compliance teams and hit those strict requirements for PCI DSS, SOC 2, and ISO 27001. I want to leave you with this one critical question to evaluate your current systems against this incoming wave of 1 billion AI agents. If an autonomous agent acts maliciously tomorrow, does your architecture have the immutable proof to catch it or the implicit trust to let it hide? As we transition from human-driven systems to autonomous ecosystems, your security architecture must evolve from implicit trust to continuous cryptographic verification. Thanks so much for joining me for this explainer, and I highly encourage you to review your identity management strategies today.